And we are talking about a barbecue, okay? The relation between the quantity of chicken that we need to buy and the quantity of the chicken and the quantity of steak. If the chicken costs $1.29 a pound and steak costs $3.49 per pound, and you have $100 to spend on the barbecue for the meat, okay? So talk to me about this problem. How many variables are we going to have? What's important in this problem? Is there only one answer? Talk to me about this problem in general.
What is the $100?
You have $100 to spend on the meat for the barbecue. And we only have two meats. We have chicken, we have steak. Those are your choices, okay? What would be some good variables to use, perhaps? What? C and S. I love it. C is for... That sounds like a joke I would say. C is for what? What about the chicken? Yeah, the number of pounds or the amount, okay? Number of pounds of chicken. And S is going to be the number of pounds of steak. Okay? All right, so I love those variables. Yes, do love them. Talk to me more about this. Ding. What? Okay, he's given me what sounds like the start of equation 1.29c plus 3.49s equals 100. What do you guys think of that? I think it's pretty good. There's one thing I'd probably change about it. So think about this. Let's say you're having, say it again. 100 minus.
Are you taking it from 100? Is that what it says?
You have $100 to spend on the meat.
So that has to equal up to 100 or...
Kind of, yeah. But let's say you're having the barbecue at your house and you are ordering this chicken and this steak, and your mom says, here's $100. Think about when you go to the grocery store. Are you going to give her any money back? Are you going to use it all? Do we know at this point? What are you thinking, Jennifer? Yes, less than or equal to, because she gives you the $100. You have $100 to spend, but how likely is it you're going to spend exactly $100? You want to get a lot of it, yes, but it's probably not going to be exact. So we're going to say less than or equal to 100. Is everybody with me on that? Because maybe it's 99.59 or something, because you wouldn't have enough. Here's my other question. Because it's an inequality, how many answers am I going to have? 2? What do you mean 2? Like one amount of chicken and one amount of steak? Is it asking you for the maximum amount of chicken? Is it asking you for a pound of chicken? If it's an inequality, couldn't you have a whole lot of different types and numbers of chicken? Do you even have to buy it per pound? Do your pounds have to be whole numbers? If you go to the deli and say, can I get half a pound of ham? You're not ordering a whole pound, right? So here, there could be many, many different answers. Many different answers, because maybe we let the amount of chicken we get be 1 pound. And if it's 1 pound, then I'm going to have a specific answer for the amount of steak that I can buy. If I let my chicken be 2 pounds, that's going to change the amount of steak I can buy. If I get 3 or 3.5 or 4 or 8, okay, that's going to be many, many different answers. So here is something I'm going to tell you that's going to help us solve this. We are going to purchase 25 pounds of chicken. 25 pounds of chicken. Okay? If I purchase 25 pounds of chicken, can you solve for the amount of steak? Can you solve for the amount of steak? Just say yes, it's quicker. Yes. Can you do that on your own right now? Just say yes and try it. Okay? So we're buying 25 pounds of chicken. Let's not even talk about what kind of chicken. Are we getting whole chickens? Are we getting drumsticks? We don't care about that. We're just saying if it's $1.29 a pound, it could be chicken wings. I don't know. All right, so I am going to be doing my work up here, so you will not be able to see it right away. And you should be trying these problems at your seat. Well, geez, hopefully they're here. Goodness. That's a lunch. Going to C. You probably have to go now. You know what that's for? Hmm? Let me write down what time you're leaving. Go. You should be working on this. Yeah. Come on. Let's do it. Come on. Let's find the steak. I don't know how much this is. I need a calculator. What's 129 times 25? Thank you. My kingdom for a calculator. Okay, then I need to subtract. Subtract. And you're like, oh, wait, this is inequality. When do I have to change that? Do I need to change that here? Oh, gosh. All right. Has anybody got an answer for the steak yet? All right. So let's see. Here's the work that I've done. Yeah, you substitute the 25 in for C. 129 times 25 is 3225. Subtract that from 100. You get 3.49 is the price of the steak times the amount of steak is less than or equal to 67.75. Is that right? Divide by 349. Divide by 349. Do I need to switch my inequalities? No, that's only when you multiply or divide by a negative. And I don't know what this is. S is less than or equal to, what is it? 19.41 pounds of steak. So my question, is this the only correct answer? It is for the 25 pounds of chicken, but again, is this my only correct answer for this inequality? No. So this is one solution, which is 25 pounds of chicken and 19.41 pounds of steak. That is one solution. But again, there are many, many different answers. Okay? So keep that in mind. Any questions about this problem? Okay. I think the key to it was less than or equal to 100 and the fact that there are several different answers. So now let's take a look at the problem at the bottom. Yeah. Right here. Okay. The problem at the bottom talks about you are going to be walking and you're going to be riding in a car. Hopefully you're not hitchhiking. We had a little discussion. Is hitchhiking illegal? I don't think it's illegal, is it?
It is.
Is it really?
In some states, not all.
Okay. Do you know if it's illegal in Indiana?
It is not.
Okay. Are we ready for this, the next one? Okay. So here, the relationship or relation between time spent walking and driving, or should I say riding. If you walk at 3 miles per hour, then hitch a ride in a car traveling at 75 miles per hour. Hopefully they will slow down so you can get in. And you are covering a total distance of 60 miles. Okay? Let's start talking about this very generally. What variables might we use? W is for, and what about this walking? So we need to kind of get specific. You're right, W for walking would be good, but is it time spent walking? Okay, the time we are walking. We're walking, and we are riding. So let's do R for riding. This is not WR for that kind of writing, but this is time we are writing. Okay. The relation between the time spent walking and, it says driving, but it should be riding. If you walk at 3 miles per hour and hitch a ride in a car traveling at 75 miles per hour, you are covering a total distance of 60 miles. Is that exactly 60? Is that less than 60 or more than 60? So that is exactly 60. Yes. So we can say this is equal to 60. All right. What else would we do here? Can somebody give me the rest of this equation? Anybody? Except for Juan, he gave the first one. Think. Did you bring your thinking caps today? Did you see the meme for today? I don't think I showed it. I don't know if I can show it. No, right now. I can't right now, but I'll have to make me show it to you. It's very cute. And I didn't even put that together. Huh? You see it? You got the equation? All right, lay it on me. And she's like, is this right?
I think it's 3W
3W
plus 75
R equals 60. What do you guys think of that? Yeah? Have a lot of head nods, a lot of bobbleheads. Okay. We already said it's a total of 60. So the relationship, how many answers am I going to have here? I said one. I heard many. Many. What's my one? What could I do to figure out one? If this is time walking, what kind of time are we talking about? Am I talking about seconds, minutes, hours? Does it matter? Ooh, it does say miles per hour. Yeah, so it should be in terms of hours. However, I'm going to tell you that we are walking for 30 minutes. Way to go, Miss Thady. Way to not follow directions. I know, right? So if I walk for 30 minutes, if this is what we call our constraint equation, saying this has to happen, this is what you're dealing with, could I just put 3 times 30 plus 75R equals 60? Why not? Yeah, it's not an hour. So 30 minutes is what part of an hour? Yeah. It's a half hour. So yes, you need to talk about this in terms of hours. So 30 minutes is going to be 0.5 or 1/2 an hour. Okay. So then we could say 3 times the amount of time we are spending, which is 0.5 plus 75R equals 60. 3 times 0.5 is 1.5 plus 75R equals 60. Subtract 1.5 from both sides. Da-dee-da-dee-da. 75R is equal to 58.5. Divide by 75, divide by 75. R is equal to 0.78. Hey, I was riding in the car for 0.78. Is that what you would tell somebody? No. This is 78 what? 78 hundredths of a... No? Because it's time. 78 hundredths of an hour, but like I said, we don't say 78 hundredths of an hour, so what would you do? What does this word of mean? What operation does that usually imply? Multiplication. So you're going to take 0.78 times 60, and you are going to get 46.8 what? Minutes. And you usually wouldn't tell somebody I went 46.8. You probably wouldn't even say 47, but you could say 47. You'd say like 45 minutes is what you'd say. But 47 is what it rounds to. So you were in the car for 47 minutes riding, and you were walking for 30 minutes. Now again, is that the only solution? No, again, there are many solutions. Many solutions. This is just one. Okay? If I said for 2 hours I was walking, then you substitute 2 in for W, and you could figure out how long you were in the vehicle. Okay? So many solutions. You just need to keep it in terms of hours. Any questions about that? All right, now let's go to page 61. Let's go fishing. Do I have any big fishermen in here? People who like to fish? Is there anyone in here who has never fished? I really don't recommend it unless they're biting really, really, really well. Then it's kind of fun. But I'm always amazed at how strong the fish and heavy they are because they're fighting. They don't want to be in there. All right, page 61. Fishing Adventures rents small fishing boats for tourists for day-long fishing trips. Each boat can hold at most 8 people. Ooh, there's a number, might be important. Additionally, each boat can carry 1,200 pounds of people and gear for safety reasons. So 1,200 pounds of people and gear for safety reasons. Assume on average an adult weighs 150 pounds and a child weighs 75 pounds. Also assume, there's a lot of assumptions here, each group will require 200 pounds of gear plus 10 pounds of gear per person. 10 pounds of gear per person. Write an inequality that illustrates the weight limit of the group of adults and children, and a second inequality that represents the total number of passengers in the fishing boat. Oh my gosh. All right, so just to summarize, we're going on a day-long fishing trip. Each boat can hold 8 people. Each boat can also only carry 1,200 pounds of people and gear. Adults on average weigh 150 pounds. Children weigh 75. Each boat has to take on 200 pounds of gear, like your life jackets, maybe some rope, and 10 pounds of gear per person. Write an inequality that illustrates the weight limit for a group of adults and children on the fishing boat, and a second inequality that represents the total number of passengers in the fishing boat. I'm not going to worry about graphing right now. So I'm going to give you 5 minutes, because we've done a couple of these together. I want you to see if you can come up with those 2 inequalities. Not asking you to solve, just try to come up with the inequalities, okay? Come up with the inequalities.